Hello fans, welcome to Susie Farms. Here we focus on agriculture, animal husbandry, aquaculture, and agribusiness, where we bring research to practice. Our products are purely organic, from the farm to the table, so we can eat healthy food. If you are new here, like, comment, subscribe to our channel, and hit on the notification bell. Permit us to serve you with some cola nut and palm wine so you can relax while watching. Follow us on Instagram, Facebook, and Twitter. Plants need the right combination of nutrients to live, grow, and reproduce. Incorrect land use and management may result in an excess of nutrients, causing soil contamination and contribution to water quality deterioration and greenhouse gas emission. Conversely, a lack of nutrient may lead to low soil fertility. So, too little or too much of any nutrient can cause problem of nutrient imbalance. Plants often show symptoms of being unhealthy when the plant nutrients are not balanced. This has become a major challenge for rural farmers, especially within sub-Saharan Africa, who sometimes use fertilizers in their farms without proper knowledge of the soil chemistry. In this video, we shall explain the two major causes of nutrient imbalance and how to rectify it. Come, follow us, let's check it out. Two of the main causes of nutrient imbalance are improper pH and higher than adequate nutrient levels, which greatly influence nutrient availability. Soil pH is a measure of soil acidity or alkalinity. It is an important indicator of soil health. It affects crop yields, crop suitability, plant nutrient availability, and soil microorganism activity, which influence key soil processes. Soil pH is affected by land use and management. Vegetation type impacts soil pH. For example, forest land tends to be more acidic than grassland. Conversion of land from forest land or grassland into cropland can result in drastic pH changes after a few years. These changes are caused by a loss of organic matter, removal of soil minerals when crops are harvested, erosion of the surface layer, and effects of nitrogen and sulfur fertilizers. Note, an addition of nitrogen and sulfur fertilizers can lower soil pH over time. Soil pH levels that are too high or too low lead to a deficiency of many nutrients, a decline in microbial activity, a decrease in crop yield, and deterioration of soil health. Calcium, magnesium, manganese, copper, zinc, iron, and boron are available to plants when the soil pH is between 6 to 6.7. Low pH levels also tie up some calcium and phosphorus, reducing their availability. If soil pH is not within the proper range, nutrient uptake is inhibited. But that doesn't mean the nutrient is not in the soil. It just means the soil chemical environment is not suitable for uptake of that nutrient. This usually takes place in highly alkaline soil of pH greater than 7.5 or highly acidic soil of pH less than 5.5. For most crops, a range of 6.2 to 7.2 is best for proper nutrient uptake. This table shows different crop yield potential at different pH levels for maize, wheat, alfalfa, and soybeans. The yield of the crop are very low as the pH levels reduce to a more acidic soil. The highest crop yield potential was achieved at a pH of 6.8. Now let's look at the measures that limit or correct acidification. If the pH is outside the desired range, recommendations will be made to either add sulfur to lower the pH or add lime to raise it. Outside the desired pH range, it is also possible for some non-essential nutrients to become more available, which can lead to nutrient toxicity. Aluminium is well known for this at lower pH. Soil pH can be managed by measures such as 1. Applying the proper amount of nitrogen fertilizer. 2. Liming to raise the pH of acidic soil. 3. Adding sulfur to lower the pH of alkaline soil. 4. Diversified crop rotation to interrupt acidifying effects from nitrogen fertilizer application. 5. Applying manure and other organic material that have a high content of calcium and magnesium bicarbonate. The second major factor affecting soil imbalance is nutrient interaction. The essential plant nutrients must be balanced to ensure proper growth and production. A deficiency in one nutrient cannot be compensated by the surplus of the other. Nutrients interact with each other, either synergistically to increase the uptake of one another or antagonistically to fight each other and lock each other out. Mulder's chart represents the interaction between 11 of the essential plant micronutrients. It shows which nutrient in the soil increase or decrease the availability of the other nutrients in the soil. Some interactions are positive, synergistic, and others are negative, antagonistic. A synergistic relationship is one where the elements involved help each other by aiding uptake or utilization. In contrast, an antagonistic relationship means the elements hinder each other's uptake or utilization. For example, adequate potassium aids in the use of iron and manganese, but if it is too high, it will hinder utilization of magnesium, boron, nitrogen, phosphorus, and calcium. An antagonized element may be present in adequate levels, but there is so much potassium present that the plant doesn't have access to it. Elements that act as antagonists can do so in a couple of ways, such as decreasing the availability of other nutrients or competing for uptake sites on the plant root. If calcium is in excess, it can simply outcompete other elements such as potassium and magnesium for uptake sites on the root. Or it can change the soil chemistry by elevating the pH to the point where iron and boron becomes unavailable. In addition, magnesium and calcium deficiency may occur in soil with excessive potassium levels. Excessive soil potassium competes for and reduces the uptake of calcium and magnesium by plants. A farmer may apply potassium without soil tests, only to have his plant show symptoms of magnesium deficiency, because the excess potassium has outcompeted the uptake site on the root. So how do we then balance the soil nutrients? The good news is that increasing soil organic matter can boost soil fertility and balance the soil nutrient system. Organic matter is a valuable part of the soil. It is the final stage of decayed plants and animals and the most effective material for improving soil. When incorporated into soil, compost produces a spongy texture that acts to increase soil water holding capacity, provides needed spore space, and lets in the air essential for good plant growth. Organic matter prevents tiny particles of clay from cementing themselves into the solid mass. This enables plant roots to move easily throughout the soil. It increases the cation exchange capacity, which is a measurement of the soil's ability to hold nutrients. While organic matter helps soil to hold nutrients and release more nutrients, it also promotes the growth of microorganisms, which helps to condition the soil. The bottom line is organic matter is a good stuff. Improvement in nutrient use efficiency can lead to substantial reduction in the use of agricultural product inputs, providing direct benefits to the environment and increasing food production. In conclusion, we can say improper pH and higher than adequate nutrient level provide more reasons for the need for regular soil testing. To apply nutrient without first establishing a base nutrient level is one of the biggest mistakes that farmers can make. Farming is risky enough, so don't ignore the simple and inexpensive step of performing a soil test. Fertilize lightly if you must, and monitor or test the soil every 2 years before adding fertilizers. I will encourage all royal farmers to continue adding organic matter into their farmland so as to buffer the soil pH naturally and retain nutrients that are released gradually to feed the plants. Improvement in nutrient use efficiency can lead to substantial reduction in the use of agricultural inputs, providing direct benefits to the environment and increasing food production. Practicing continuous no-till, cover crop, application of solid manure, and diverse rotation with high residue crops will help to increase organic matter content and improve the soil buffering capacity to limit changes in pH and improve soil health. The relationship between soil nutrient levels and plant nutrient levels is complex. The ability of a plant to absorb any given nutrient is affected by the pH, temperature, moisture, as well as the amount of other nutrients within the soil. For this reason, it is very important to correctly diagnose symptoms of deficiency and toxicity before taking corrective action. Otherwise, you risk solving one small problem only to create another big problem. Please kindly share your own opinion about soil imbalance in the comment section below. Don't forget to subscribe and hit on the notification bell so you will be notified when we post our next video. Thanks to all our returning and new subscribers for watching. We would love to see you here again. Don't forget to share your own opinion with us. We encourage all farmers to use organic fertilizer that releases nutrients slowly to avoid leaching. See you next week. Cheers.